Hi, my name's Rob Pope, Senior Consultant and Partner with Ecolite Energy Solutions. And it's my pleasure to present on behalf of the Regional District of Okanagan-Similkameen this fourth of a six-part series on the subject of best practices in building planning design, compliance, best practices in building envelope, and high-performance HVAC systems. In the first three sessions, we covered strategies for building energy efficient homes. We discussed the energy and zero carbon step codes and their compliance requirements, and we covered working with energy advisors. Today, we're going to cover the role of the building envelope in high performance homes and go through some strategies that will help achieve high performance for the building. Other chapters in this series will include heating, cooling, and ventilation, and finally, working with your builder. The building envelope is the skin between the conditioned living space and the unconditioned outdoor environment. It's the boundary between indoors and outdoors. The envelope is a multi-functioning and critical component of any building and controls how air, heat, and light move in and out of the home. It affects energy efficiency, comfort, health, and sound. As you can see in this graphic, each component of an envelope assembly, such as an above grade wall, for example, has at least one or more important functions. Combined, they need to manage water, air, heat, vapor, fire, smoke, and sound. How well the building envelope functions will have a direct relationship on the size, type, complexity, and cost of the mechanical system. That's why, first of all, it's important to determine the envelope before even considering the mechanical system. It's also better to focus first on optimizing the building envelope. When you think about it, the envelope does not need to be serviced once or twice a year, doesn't need filter changes and technical adjustments on a regular basis, and will outlast the life cycle of any mechanical equipment. The better the envelope, the simpler the mechanical system. There are a number of things we can do to improve the building envelope. We can lower the window to wall ratio, less windows, the better. Increase the wall R values. Increase the window R values or USI values. Decrease the window solar heat gain coefficient. Minimize the thermal bridging by simplifying form factor. And finally, improving air tightness. Lowering the window to wall ratio. Glass, doors, skylights are the weakest links among all other envelope assemblies. The less of them, the easier it is to manage heat loss and gain and air infiltration. Increase wall R value. The more insulation you have in the walls, the more it slows down the transfer of heat coming in or leaving. However many windows there are, or how much window area you have, it's always a good practice to make them high performing. Remember, they are the weakest link in the envelope. Triple pane is better than double. Windows with a lower solar heat gain coefficient will reduce the amount of solar gain and therefore lower the cooling load. Minimize thermal bridging and simplify the form factor. A square box is much easier to heat and cool than a home with complex geometry. Every corner, every intersection of vertical and horizontal planes where walls meet floors, for instance, creates more thermal bridging where wood or steel structural elements leave little or no room for insulation. And finally, seal the house tight to prevent the uncontrolled movement of air coming in and out of the home. In other words, improve the air tightness as much as possible. There are three main reasons for making a house tight. Moisture. We don't want moisture to accumulate and get trapped in our walls. Heat loss. The less infiltration, the less energy waste. Comfort and health. The more airtight the house, the less draftiness, less odors, less noise, less contaminants, and less mold. To make a building airtight, you need a good air barrier. And an air barrier is a system that prevents air, heat, and moisture from moving in and out of a building. It can be located anywhere in the building envelope, inside, outside, and in between, all depending on the type of wall assembly and how the effective required R value is achieved. It has three major requirements: impermeability, continuity, and durability. What is air impermeable? Well, air can't get through it. It needs to prevent infiltration, which causes heating and cooling, energy loss, and allows moisture and condensation to collect in the walls. Condensation creates mold and mildew, which is unhealthy and causes structural damage. The air barrier has to be continuous. For the air barrier to effectively protect the building, it can't have gaps in its continuity. All components in the envelope need to be interlocked with the air barrier. The roof system, above grade walls, windows, skylights and doors, the below grade system, and any exposed floor system. And finally, durability. It has to last over the lifetime of the building and not be degraded by UV. It will not discolor, break, or split, and will remain intact throughout the construction process. There is more than one way to achieve the ultimate energy target of the building with the wall assemblies. For example, exterior insulation will reduce the thickness required of the wall, or make the wall fatter to make room for more insulation in the wall. Another is using two framed walls with an air gap between them to reduce thermal bridging. All these options will depend on the building design, level of energy performance, cost considerations, constructability for the builder, and local bylaws. Below grade assemblies. These assemblies tend to be a little more complex than the above grade assemblies. In previous times, it wasn't a surprise to find homes with cold basements with odor and mold. An airtight, well-insulated basement fixes a lot of potential issues. Now here are some of the key considerations for below grade assemblies. Drainage, to deflect water away from the foundation wall and to prevent hydrostatic pressure. Detailing of the wall to ensure continuity of the water resistive barrier, air barrier, vapor barrier, and insulation at the below grade to above grade wall transition. Waterproofing or damp proofing these assemblies is important to avoid water penetration, and it's important also to use durable material. A popular option to framed walls is insulated concrete forms, ICFs. It can be used for below or above grade walls, and it's a bit like building with giant Lego. There are many reasons this method of construction is gaining traction, such as energy efficiency, durability, fire resistance, and more. However, as always, its benefits will have to be measured against cost, construction time, and the builder's experience with these products. Here's some additional resources for Part 9 buildings. BC Housing in particular has some very useful publications, guides for good practices of building envelopes and high performance building in general. And that brings us to the end of this fourth chapter on building envelopes. And just to remind you, other chapters in this series will include Introduction and Strategies for Building an Energy Efficient Home, Energy Step Code, Zero Carbon Step Code, and their compliance requirements, working with energy advisors, the building envelope, heating, cooling, and ventilation, and working with your builder. Thank you very much for your time.